Alright everyone, today we are going to be learning the ratio test. The ratio test is a test for determining the convergence or divergence of a series. So you have your basic series, and you do, as the limit of n approaches infinity, n plus 1 over a to the n, and that equals L. So what you get from that, if this basic thing, the limit of n approaches infinity to this, if that is less than 1, if what you get here is less than 1, your basic series is convergent. But if it's greater than 1, if the answer you get from this is greater than 1, the series is divergent. Finally, if you get an answer that equals 1, you can't draw any conclusions from this, and you pretty much wasted your time. So our first example here, n squared over 2n. So the first part, you want to do the limit as n approaches infinity, absolute value signs, n plus 1 squared over 2 to the n plus 1. And then you're going to be dividing it by your first function, so you can flip and multiply instead. So flip and multiply, you have 2 to the n over n squared. So at this point, you're going to want to start canceling out from these two sides. So for example, you can do 2 to the n. This will cancel out this 2 to the n right here. But remember, you'll still have this 2 to the first power, so you're going to have a 2 down here. You cancel out this n squared with this n squared, and you're going to have 1 on top. So after canceling out, you're going to have this 1 left right here, and this 2 left right here, and you'll get a final answer of 1/2. So 1/2 is less than 1. And from that, you can determine that your series is convergent.
And now moving on to a second example here, where we have x plus 2 to the n over n minus 1 times 2 to the n. So what you're going to want to do is, again, start off by drawing a limit as n approaches infinity of the original function, except instead of n's we have n plus 1. So we have n plus x to the 2 n plus 1 over, now n plus 1 minus 1 will just give you n, times 2 to the n plus 1. And then again you can multiply by the reciprocal, so, of the original. And then we have n minus 1 times 2n over x plus 2 to the n. And now what you're going to want to do again here is start canceling. So the 2 to the n will cancel out with this 2 to the n, and that will still leave behind a 2 to the 1, so just 2. And then here again we can cancel the x plus 2 to the n with this x plus 2 to the n, leaving x plus 2 up top. And then as you take the limit of n approaching infinity of n, that'll be infinity, same as n minus 1, that'll also be infinity, so we can cancel these two terms here. And so what that's going to leave us with is x plus 2 over 2 is less than 1. And what we're going to want to do is bring the 2 over to this side, so multiply by 2, leaving us with x plus 2 is less than 2. And what this 2 is right here is that is your interval of convergence. And how you're going to want to figure out each specific point is to add 2 to each side, and add 2 to the right side, and also subtract 2 to each side. And so what that would leave is the interval of convergence being 0 to 4. Here are two more problems that you guys can do on your own using the ratio test.